Hey Farmaan, how are you today?
Yeah, I am doing good. How are you?
Hi Farmaan, can you hear me?
Yeah, is it live?
Your audio is a little on the lower side.
Okay, yeah, is it live?
Yeah, it's live. Farmaan. Cool Farmaan, I think. What is that?
Okay.
Yeah, cool. Hi everybody, welcome to today's conversation on building offline first products. I have Farmaan here with me, right? Who's going to talk about building offline first apps. So, welcome everybody, and thanks for joining the conversation today. So, Farman, why don't you take it over and share your screen?
Okay. I'm sharing my screen. Just check. It's not showing up. Is it visible? Uh, so can you confirm? Is it visible? Hello. Okay. Let me share once again. Let's see my screen actually. Uh, so, yeah. So is it visible?
Farman, can you share your? Can you start presenting?
Let's try. Okay. Mm, I'm. Let me know once. Is it?
No, no, a blank screen is visible. Now the other slides is visible. Yeah, now it's
Okay.
visible. Okay, I'll
Correct.
drop off. Yeah, why don't you continue?
Let me start from the beginning. Okay. Yeah. Yeah. So good afternoon, everybody. Yeah. Welcome to my new talk, building offline first apps. Okay. The problems bit of it. So yeah, this is a new talk in this series, building for India. So let's get started. Okay. Before that, do subscribe to the newsletters where we post uh, all the presentations, the blog post, and all. So to get updated on all the new talks which we are giving, just subscribe to this newsletter. Yeah. Yeah, so agenda for this talk, it's going to go through what are the general problems with normal apps, what is the offline first apps, what are the challenges in building an offline first app. In this talk, what I want to mostly talk about the challenges bit of it. And in the subsequent talk, I want to, I'll be talking about how we can solve those challenges and build a robust offline first app. Okay. Yeah. So before moving, let me introduce myself. I'm Farmaan, one of the partner at Previous. I mostly work on the technology side of things and a bit on the business side. So over the years, we have worked with multiple companies, ranging from Kusa Labs, Google, and Paradigm. Recently, with NoPay, and yeah. So okay, so let's get started with the talk. Okay, so what's the problem? Okay, what's the problem with a normal app? Okay, so before telling what is the problem, I want like how a normal app works. Okay, so you have the three layers. Okay, I'm skipping a lot of nuances here. Let's say view model and all. So to keep things simple, so even there are three layers. You have UI, you have network, you have cache or database, whatever you. Okay, and something on the UI triggers a network call. Okay, and that network call in turns caches the data. If there's a cache, the data is being cached. Okay, and then the same result is being sent to the UI, and the combination of the cache shows a new UI. Okay, so assume you are building, let's say, a Facebook app. Okay, entering the home screen is basically the trigger point. You hit the Facebook API, it caches something on its cache, and then shows it a new UI. Okay, so this is how almost all the apps work. Okay, which are not offline first. Okay, this is how it works. You can look at Swiggy, Zomato, mostly. Okay, okay. So what is the problem in this? Okay, so we have to see. Okay, there are connectivity issues. Okay, there can be network flakiness, what not. You might be in an airplane. Okay, at that moment you might not be able to use an app. Let's say you have an email app. Okay, and that only works while you're online only. Okay, that I can send an email only when I'm online. I can read my email only when I'm online. So you can see there will be instances where we'll not have good internet connectivity or no internet connectivity, or if the internet connectivity is very flaky. You are in an airport, you are in a train, in an elevator, whatnot. Okay, and this network connectivity the issue with this network connectivity is that you will not be able to show your UI just because your UI depends upon your network. Okay, so let me just go back to okay. Yeah, network connectivity is very it's a key problem in a normal app. Okay, so let me tell you how things will feel. Okay, so you have UI. Okay, and let's say for some reason you lose the internet connection. Either you have it doesn't have internet connection, or you have low bandwidth, whatever. Okay, so if you don't have your network connection, your UI will be empty. Okay, your UI will be empty. Or if let's say you have cache, okay, you can still show data from the cache, but the user will not be able to do anything. Let's again take the example of an email app. Okay, I can see all my email, but I won't be able to do anything with. I cannot send a reply to it, or I cannot remove it from my move a email to a spam. All of those I cannot do when I don't have internet. And yeah, so this is a challenge when an app purely depends upon a network. Okay. Now another problem is people generally hate waiting. Okay. It is seen in multiple surveys that okay about 50 to 55% of user drops off if your app take a lot of time to load. Okay. If your app is heavily dependent on network and your network is flaky, it will definitely take more time to load. It might not fail, but it not might not show an error, but it will definitely take a longer time to load the content itself. Okay, and the longer the time it takes, the chances of user dropping off from that journey itself is very likely. Okay, so the third is high data cost. Okay, yeah, in India, it's after this post geo revolution, the data might be cheap, but across um, the globe, if you see the average data cost for 1 GB of usage is around 6.8 dollars. Okay, so you can see how costly is this data. The data is okay, especially when you see an African country. where the income is not very high and we don't have that high internet penetration. The cost of data, prevents them from using an app. Okay, so that is the challenge. Okay, if your app doesn't work in a good, if your app only works in a good internet connection, then you are losing a lot of customers. Okay, so apart from this, there are many studies. Okay, recently there was a study, about 37% of millennial decides, okay, if they want to keep an app installed or not, just based on the fact that if it is a high data usage app, they'll most likely they will not be using it. 30% of the millennials said that they will not be using it. Okay, so that's there. So yeah, so all of this can be solved in kind of an when we build an offline first app. Okay, where you load data whenever it's needed only, not when just because I'm opening a UI, I'll just load the data. Okay, it is always there for me to consume. Okay, so okay, what is offline first app? Okay, so clearly it's an application development paradigm. Okay, basically it defines you how you want to build an app so that app can be used. Uh, if you don't have internet connection or for a intermittent period of time, let's say you logged in on an app and you don't have internet for the 5 days, you can still use the app. I can still see all my emails. I can still see consume all my email, all my content. Let's say take example of YouTube app. Okay, if my YouTube app, the part of YouTube app is offline, you can still consume content. Okay, so it's also just not about just consuming content. You are reading the data. Okay, and then you are making changes to it. Again, take an example of the email app. I can mark an email as a spam or mark my email as a archived or something. Okay, so all of these changes can be performed even if you are online, offline. Okay, your app is the behavior does not changes if the app is online or offline. Okay, and yeah, so you can almost all the good apps, okay, all the top 10 apps if you see, works in offline in some way. This is just an example of the Gmail app. Okay, so you can see I can see all my emails. I don't have internet, but I can see all my emails. Okay, even I can see all my ads as well. Okay, so that's the first screenshot. The second shows you that I have sent an mail. Okay, but at that moment I was offline. Now the app knows that I am offline. I don't need to be online to send an email. I can still send an email. Okay, reply to email. Okay, and everything will work. Okay, as and when you have internet connectivity, all whatever actions you have performed on the app will be sent to the server, and it will act like there is no internet issue at any moment. Okay. Similarly, if you see Twitter as well, okay, you can see on the left, you can see I can see all my tweets even if I'm offline. Okay, on the right, you can see I have tweeted something. Okay, but then I was offline. It shows me that there is a tweet, but that tweet has not been sent. Okay, as soon as I have internet connection, that tweet will be automatically sent. Okay, so I can just write, do all my actions. Okay, like a normal, assuming that I have internet connection. Okay, and everything will as it is. Okay. Another example is kind of to do list. Okay, to do list. Okay, I have created a project on to-dos. I created multiple to-dos. I can even search all my to-dos. Okay, some apps give you that functionality of searching, some don't. Okay, depending upon the use cases and all. Okay, even in to-dos, you can even search all your content even if you're offline. Okay, so it acts like a independent app which might not even need a server to run. Okay, yeah, so that's that. Okay, all good. Okay, we have seen example of all the offline first apps. Okay, but the complexity, if you see everything looks simple. If I just go back to this, it looks simple that okay, my emails will be sent. Okay, or my tweet will be sent as soon as I go online. Or whatever I've done, I have added a 10 to dos, or one created one project here and added three to dos. Then I can even search it. All of this looks simple, okay, but at the core of it, building an offline first app is a really challenging work. Okay, um, to build an offline first app, you have to understand a lot of nuances, what can go wrong, okay, before even thinking of how to build it. Okay, so the first challenge is making data available offline. Okay, like I said, your app might not even need network to work properly. So for that to work, so that you can show the content to the user and user can interact with those content, you have to keep all your data available offline. Okay, and that data can be anything. Data can be a normal JSON, or it can be a multimedia file. Okay, take an example. If I'm consuming an email, and my if I'm just only keeping my email content text offline and not the attachment, I'll not be able to use the app to its full potential. Okay, like you see, multimedia can be kept offline. Metadata, the text and the subject, the sender information, all of those can be kept offline. Okay, and you can still use the app, make all the changes you want. Okay, and those changes can be sent to a server later. Okay. Yeah. Then the second very important part is, you have fetched the data, you have caching it, you're keeping it all locally. That itself is a challenging work, and to do it at a scale. Okay, and and so that, okay, at any moment the user uses the app, it sees the latest content. Okay, so that is this challenging part. Okay. The second challenging is basically whatever actions you have performed on an app. Okay, that action needs to be sent to your backend so that even the backend state can be updated. Okay, so let's take an example of same email app. Okay, I am what I'm doing here is, let's say I have opened a Gmail app. I have opened an email, okay, and I have replied to it. Okay, reply can be an action. Okay, it might be an offline first app. It will work smoothly. Okay, it will just tell you that, okay, I have taken your reply. Okay, now you don't have to worry. Everything will work as it is. Okay, but then the challenging bit is, how do you ensure that reply is sent correctly to the backend whenever you have it written? Okay, it's in the same order. Let's say, another challenge I can give you. Let's say, you want to send an email. You have sent an email. Okay, want to send an email. You have drafted it. You have saved it. Okay, now it's in a draft. Okay, and then you want to send it. Okay, so what happens is, here are two to three action happens. You create an email. You put that email to a draft. Then you send an email. Okay. And assume, after I have sent an email, I want to delete it from my inbox or my sent items. Okay. This is the fourth thing. Okay. Those four action has to be sent in the same order that the user performed. Okay. And this is a challenging bit. Okay. If you fail in any doing any of this in the same order the user performed, there are high chances that your data will be in inconsistency. So, let me just give an example how it will fail. Okay? Let's assume, okay, we have sent an created an email. The email, assume that API was successful. Okay, okay. Now you have, on a backend you have a email being created. Okay, now you have added a text to it that was successful. Okay, now what will happen is, you will write, you are actually trying to send it. Okay, and then you are trying to delete it. But if the delete operation API is sent first comparing to the send operation, the chances are that you'll not be able to send that email. The subsequent API of sending an email will fail because the email you have deleted it. Okay, so that's it. Yeah. The another is conflicts. Okay, when more than one client are working on a single entity. Okay, let's say let's say take a notes app. Okay, let's take an example of notes app. You're writing in the same line somebody else is writing. Okay, there are high chances that whatever you have written can conflict with somebody else. So somebody else, what somebody else has written. Okay, and in doing so it can create a conflict. Okay, and your data will be in inconsistency. Okay, so how to go about solving it? It's not a simple process to figure out how to solve it. Okay, so let me give you an example how things will feel. Okay, so let's assume, okay, this is a timeline. Okay, and you have two clients A and B, and you have a server. Okay, then you want to change an entity. Okay, entity one, assume that entity ID is entity one. Okay, at 9 o'clock, okay, both client A and B were seeing the same version of the entity as whatever was on the server side. Okay, now what happens is, at 9:01, okay, both client A and client B goes offline. Okay, now they don't have internet. Whatever actions they are performing, it's stored locally. Okay, stored locally so that it can be sent later. Okay, the third one is, user client B makes a change. Client B makes a change. Let's say it adds a new line. Okay, or there was the first line. Client B makes a change to the first line in the text. Okay. Okay. Then what happens is client A also makes a change to the same document exactly at the same place. Okay. So now what happens is, if uh, client A goes online, okay, what will it see? Will it see data from only from what he has done on the server? What will be the state of the server here? Um, okay, so just because client A does not know anything about the changes what client B has done, or the server even does not know, okay, because the server B is offline. Okay, so the client A data will be sent to the server, and server will assume that this is the latest data. Okay, now entity B also goes online. Okay, but you can see entity B made the changes first. Okay, now what will be the state of the entity one? Okay, what will be the state? It's might not be very clear. It might not be very obvious itself. Okay, what will be the state? Okay, um, no. Okay, and at 9:06, okay, none of client A, client B are in a consistency. Whether changes from client A is not there in client B, changes from client B is not there in client A. Just because at 9:04 we decided that the client A data was the latest, and that was accepted on the server. Okay, if I make changes to if I now accept client B, then it will override the changes which were done by client A. Okay, you can see there are conflicts when more than one client tries to interact with the same entity. Okay. So there are multiple strategies to solve it. The first one being is, just don't care. There's a conflict. Okay, that's it might look like very naive approach, but trust me, this approach is being used by fairly big companies. It is used by Firebase actually. So whatever data comes first on Firebase is treated as the correct data. Okay, so here basically you treat whatever data comes in. Let's say here, if I go back here, so here, so client B will be the winner here. Okay, so there are some strategies which might work for certain types of apps. Okay, let's say this might not work for a note taking app. Okay, but it will work for a fairly simple app, let's say email app. Okay, so where the chances of such conflict happening is very low, because there are minimal collaboration and in that sense. Okay, and even if you're the other person you're checking on, if you're making changes, if you as a user making changes on a two different client, then you are it's you are yourself aware of the changes you have made. Okay? So there are very, if there are very less chances of having a conflict. Okay, less chances, or that the data is not very widely shared. Okay, this would be the go-to strategy to solve conflicts. Okay, we will discuss how to implement all of this. Okay, in the upcoming talks. Let's move to the next strategy. Okay. The next strategy is basically versioning your objects. Okay. So let's say you create an app. So you created an email. Okay. You added a subject to it. Then you added a text to it. Each change creates a version. Okay. And each version has a parent. Okay. Where we're keeping track of what was the parent of that version. Okay, at any moment what we see, if there are two versions, okay, with same parent, we decide this is a what do you say, there's a conflict. Okay, there's a conflict and now we have to resolve it. Okay, so this is something similar to how Git works, where you see there are, it defines, okay, what is a parent, and if there are two parents there are chances that there will be a conflict. Okay, similarly, like you can adopt last twin strategies, or you can merge it. Okay, this strategy you can see, okay, this kind of problem. Okay, if you've used Google Docs, okay, if you've used Google Docs, and Google Docs is also offline in some devices. Okay, this is the strategy they use. Okay, and there is an algorithm behind it. It's called operational transformation or not. If you want to merge data, okay, so that's it. Once the data is being merged, okay, the client, what will do is it will fetch the updated data. That's the only thing it will do. Okay. Okay. The next thing is basically not caring about the changes, what needs to happen. Okay. Here you represent all the user actions. Okay. In terms of operations. Okay. And create only a local version. Okay. Let's say I want to send email. Okay. Um, what I will do to implement this functionality is basically I will create a new email instance locally. Either it be in a cache database, doesn't really matter. But in this handling of conflicts, um, you create a local email instance, and you then send the API to your backend whenever you have an internet connection. Okay, you send an API. So what happens is the API will perform that action. Let's say email was to send an email to farmaan@rivers.com. Okay, so it will create an email, it will send an email. Okay, do everything, and it, what happens is once it is sent, the all the business logic what needs to happen, it will happen on the backend, and the result will be eventually sent, and it will replace the changes which you did. Okay, so you can see all the changes which you did is being replaced. Okay, so the key here is to mimic the changes what would have happened on the server side, on the client side. Okay, so you can see an example of this being used on superhuman email client. Okay, where they batch all the operations and send at once and get a aggregate of the data at once. Okay, so that was all about handling conflicts. Okay, but then we'll discuss more detail on this, how to handle on a very specific scenario in upcoming videos. Okay, the next problem is handling deletes. Okay, okay, this is very nuanced problem you'll face. Okay, so let's say there are two devices, two clients which are offline. Okay, both have the same record. Let's say record A. Okay, um, if the client A and B are both offline, client A deletes a record. Okay, and it goes online. Okay, it goes online. Now how the client B will know that something has been deleted? Because how will you know that something has been deleted if the data itself is not there, right? So there are multiple strategies to solve it, where you don't delete any data, you mark the data as deleted. Basically you convert a delete operation to an update operation. Okay, so that you know that okay, there was a data, now it has been marked as deleted. Now on the client side, that data will not no more be shown, assuming that that data is being deleted. Okay. Okay. Next thing is defining what is offline and online. Okay, not all the apps will have all the section online offline. Okay, there might be key critical section which you want your user to use offline. Okay, things like email, um, seeing your email, but searching history of your entire email history. That might be a very huge operation if you perform on the client side. Okay, so you have to build a proper UX around it and telling that okay, this functionality is needs an internet connection. Okay, so it's not an hard and fast rule that entire app has to be offline. There might be some certain section that's authentication search can be online only, and the core component of the app can be offline. Okay. Okay. The next critical part is the file uploads. Okay, if you want to build an offline first app, you like you are making certain changes on offline, let's say deleting a email, or you're creating an email. Okay, then it involves some multimedia uploads as well. Okay, how will you perform that action? Okay, there are nuances to it. Okay, can give one example. I've just said one example of it. Let's say um, you were creating an email, you added a file as an attachment to it. Okay, you are given all the enough permission. Okay, let's say whatever the syncing strategy you have. Okay, just because you don't have internet, that file won't be uploaded. Once you have internet, the file will be uploaded. Okay, but that the period between not you selecting a file to be uploaded and file getting actually uploaded, a lot of things can happen. Either the file can be deleted when the upload is happening, what will happen in that state, or the permission you are given to that file might be revoked. Okay, so what can go wrong? Okay, if you see, there are multiple things which will go wrong here. The file might be deleted, or the permission might be revoked. So these were certain some of the nuances in building an offline first app. Okay, I'll talk about more of how to solve each of the solution problems in detail in upcoming videos. Okay, so, but I want to just give an overview of how an offline first apps are built, so that you know the next step what you are expecting. Yeah, the first step is defining a single source of truth. Like in the first slide, I said mentioned that okay, you are reading data from your network, you are reading data from your cache or database. If you have to build a good offline app, you have to define a single source of truth. Okay, there cannot be for a specific component, any component which is offline. It there cannot be two ways about it. That okay, I am receiving data from network and some cache as well. It always has to receive the data from a source which is available always. Okay, even if you don't have internet connection. Okay, next is basically how will you be thinking up and down. Okay, basically thinking up in the sense that all the changes you have made while you are offline to the server, and fetching all the changes somebody else or made on an entity which you seeing at that moment, or the changes you have done on a different client. Let's say you are working on a mobile app, you made a change on the web app. Okay, how does that happens? Okay, next is retry. Okay. Since all of this happens, all the syncing happen in background because you don't have internet, everything is accepted, everything is optimistic that okay, this will succeed. Okay. There are high chances things will fail. Okay. Things can fail because of temporary errors, permanent errors. Okay, temporary error being that okay, your server is unavailable, or a permanent error that okay, your data is invalid. The API request which I sent is invalid. Okay, how do you handle all those errors? Okay, gracefully, so that your UI, the data which is there offline is consistent. Fourth is idempotency. Okay. This defines basically whatever, if a user has performed an email, creating an email operation once. Okay. This, the same thing has to be sent only once on a server. Okay. Server has to process it only once. If it's processed multiple times, the chances of showing multiple similar emails are very high. So this has to be taken care of while you are building an offline system. Okay. Again, like I said, conflict resolution. The implementation of it is done. Um, we'll talk in the upcoming videos. Okay. In file upload, offline file upload. Okay. What are the strategies you can pick up? Okay, so that your file uploads can work smoothly. Okay, even if a file permission has been revoked or the actual file has been deleted, how do you ensure that the file still gets uploaded? Okay. And again, then there is background sync. Okay, all of this. Okay, since everything is offline, at any moment things can change. Okay, you should always be ready to refresh the current data. Your app should not show a stale data. Okay, there has to be some kind of background thing happening to ensure that your data is always up to date. Yeah, with this I conclude my talk. So we can reach out to me on my email or on social media. So, yeah. So we'll be having the next talk on this, detailing it out, how an actual offline first app is being built, going through each detail, each nuances in very detail, coming up with strategies how to solve those problems. Okay. Yeah. Yeah. With this, I conclude my talk. Do subscribe to this newsletter, to the newsletter, and we'll be sharing this presentation and the blog post for the same on this newsletter. So, do subscribe to it. Okay. Yeah. Thank you.
Great, Farmaan. Do you have some examples of like great like offline first apps, especially in the Indian context, right? Since we're speaking to a lot of like developers, product managers, entrepreneurs in like India, a lot of developing
Okay.
countries. What apps would you suggest?
Okay. So, can I detail this question a bit? The India context in the sense what? Let's say, do you tell that Twitter is India context or it's not
No,
India
no, no.
context?
Any like these are great examples that you showed. Any India-based apps, right? Like apps made in India that are doing really well, right? I know a lot of the edtech startups are doing a really good job,
Absolutely,
uh,
yes, yes.
like
So
showcasing.
you can see, yeah, a lot of edtech startups where they make the app offline so that the content is available. Because for a student, okay, who's getting that lesson, okay, they might not have enough data because in India we have this geo thing, 1.5 GB per day. That's the common plan most of the user have if they a geo user. And if that gets expired, how do a user use the app? Okay, so keeping all of this in mind, a lot of ad tech companies you build system around it so that the content, let's say the video, or the lessons they want to consume are available offline whenever they need it. Okay? Example can be, I guess, an academy is kind of good example where you can see download all the contents and consume it. But then there are a certain section of the app will be offline. Then there are certain section which might not be offline. One another app I remember, it's kind of a company which we work with, called LIC Super Agent, where the app is being used by LIC insurance agent to create presentation so that they can share the presentation to um, a, a prospective buyer. Okay, and all of this works offline without any internet, um, without need of any internet. Yeah, I
Correct,
hope that
correct.
answers.
LIC, yeah, LIC agent is super agent is a really interesting app. There were actual LIC agents who are guards in the day and who are LIC agents in the night, right? And and they used to work fully offline. They used to go to their client place in the night, and they didn't have internet connection. They would just need to create these marketing posters on WhatsApp, right, and share it with their clients, right? When they would go home, they would have a Wi-Fi, and that's when the entire marketing presentation would get synced with them, right? So the
Yeah.
entire presentation creation, everything would work offline.
Yeah,
Really
another I remember we worked with one of the another clients called Internet Sathi, where these were rural women taking surveys, going door to doors and taking surveys. Okay, for them the internet availability of internet was not that great. Okay, all of whatever they had to do had we had to ensure that okay that works fully offline. And they can fill up any surveys uh, at any moment they want, and whenever they have internet, it might be the next day or day after, a couple of days after that. Okay, the data gets synced to the server, and mm, the user at that moment does not need to have internet connection.
Yeah, that is another great example, right? So, women in rural India, again, going across different villages, and many times they don't have great internet connection, right? So they would be offline by default. We actually met a lot of these women, and they would fill up surveys, which are over 200 questions, right? At any time, you should be able to save your survey, you should be able to resume it, you should be able to send it, all completely offline. It's a very great example as well. Yeah, it would be interesting to see some of these examples or some of these use cases covered in some of your upcoming presentations.
Absolutely. I'll try to cover all of these common use cases. I'll take example of this survey app. If you want, we can build an offline first app for a survey, if that works.
Perfect. Sounds good. Great. So, I don't think we have any questions right now. So, yeah, thanks everybody for joining in today. We have a lot of, interesting talks coming up. In case you're interested in talking to us, again, hit us up on LinkedIn, Twitter, email. We'd love to again connect with you and share our thoughts. Cool. Thanks everyone. Thanks, Farmaan. Bye bye.
Thank you.